Hello everyone. I am back with 5.2 Math 110 graph of the exponential function. So graphical features of exponential functions. For the first thing, 0a is a vertical intercept. So you see in here, under here, there's like a table with 4 cases, but all cases have only one vertical intercept, which is the same as 0a. And remember that a is the initial amount of the exponential function. Y equals 0 is a horizontal asymptote. So in here, y equals 0, which is x-axis, is a horizontal asymptote. And the domain of the function is all real number. When you talk about the domain of exponential function, it's just always all real number. Okay, you don't have to worry about any value of x because it's all valid. But for the range, you should know that for exponential function has to be greater than 0. Okay, so when you look at it has to be, so the two actually it could be like from it could be 2k. Okay, it could be 2k, but this one missing 1k. It should be 0 comma infinity, positive infinity, or it could be negative infinity to 0. So for a greater than 0, it is for a less than 0. Okay, so I may have to separate that. So you can see that the range of the function will be greater than 0, not equal 0, right? Greater than 0 and keep going up to the positive infinity if a is greater than 0. You see that? To this k, if you see at the range of the function, you see that it shares from 0 to the positive infinity, both of these cases, right? And both of these giving you like a greater than 0. So that is the things. But for a less than 0, you see that the graph is from is going down from 0 to negative infinity, right? Remember that it's not equal 0. Okay, so that is the thing for the range. So I'm gonna delete this. Okay. Now, for the case that's a greater than 0 and b greater than 1, you see that this is like a growing exponential function, or increase. The function is increasing as x increase. So you can see the graph is going up, but for the case that a greater than 0 and b just from 0 to 1, you should know that this is a decay graph, and you should know that from left to right, the graph is going down from positive infinity to 0. I mean, you cannot touch 0. It just go along with the x-axis and try to get to 0. Okay. For the second case, when you see that a is less than 0, right, and b is greater than 1, in this case, if you it like a opposite way for growing and decaying. So in here, it's actually like a decay, right? And you see in the graph, you should know that its decay is decreasing from the left to the right, and the last case in here is a less than 0 and b is in between 0 and 1. So then the function is growing from negative infinity to go to along with the horizontal axis. So that is things. Now let's me move down. Okay, so this is the page for the introduction. Okay, I would love to let you guys read on this, and we're gonna move to the next page. But the main thing in here you may think you may read is the exponential function give us another layer of insight for predicting future events. That could be a good statement for you later to use on the problem here, on some problem down here. All right. So let's go with problem number 1. They want us to complete the table for fx equal to 2 to power x and below, and then sketch the graph of the function on the axis provided. And then finally, state the domain, range, vertical, intercept, and asymptote. Okay, so so the left hand side is x, the right hand side should be y equal to lx. Okay, and they put some value here. Let's start with 0 here. Let's see. If you have x equals 0, then I have 2 to the power 0 equal to 1. Okay, so right away, you know that this is the y-axis, y-intercept, sorry. So you have 0 and 2, right, y-intercept. So let's put here is vertical intercept is y-intercept here. Okay, I'm gonna circle it to make sure I don't forward it. Okay, and then 1, if we have 1, then I have 2 to power 1 is 2, right? And 2 to power 2 is 4. And I have 2 to power, so here's 1, 2. 2 to power 3 is equal to 4 times 2 is 8, right? Okay, so I have some other order pair as 1, 2, 1, 2, 2, 4, and then 3, 8. Okay, so let's coordinate it. 1, 2, so 1, 1, 2. Okay, 1, 2. Is that right? 1, 2. Oh, sorry. This I'm missing. I messed up in here. It should be 1. It should be 1. Yes. Sorry, everyone. Yeah. So it should be 1. And then 1, 2. Okay. And then 2, 4. 2, 4. What else? Say 3 and 8. 3, 8. Okay. So let's say I want to know some value in this actual. So what should I do? Let's choose a number. Let's say to -1 and see what happened. I have 2 to the power -1, which actually equal to 1/2. Okay, so that is over here, right? So if I choose some, I'm thinking if I choose something like maybe, I don't know, maybe -2. Is that going to be like a negative number for the y value? Let's see. So I have 2 to the power -2, and if you remember that, say a to the power -b or negative something, say b, then you're actually gonna have 1 to the power a to the power 1 over a to the power b. Okay, so the negative power will never give you a negative number, because why? It's just gonna give you like a reciprocal of a to the power b. Okay, so let's we come back with the problem. So I have 2 to the power 2 2 to the power -2. 2 to the power -2. Oops. And that will be equal to 1 over 2 to the power 2 is 4. So 1 over 4, right? Similarly, if I have a negative of 99, and what do I have? 2 to the power -99, which equal to what? 1 over 2 to the power 99. And that's really a very big number. And now I'm gonna say is try to go to 0. Okay, it's become like a close to the horizontal axis. So so that mean what? That mean this is the y-axis is the asymptotes, or I'm gonna say, sorry, axis is asymptote, or I'm gonna say y equals 0 is the asymptotes, horizontal asymptote, horizontal asymptote. Okay, so I will draw, maybe I try to make it look like close to 0. Okay, and it's keep going up and up very quickly. Okay, so that is the way our function look like. What else do I miss? domain. Okay, domain, as I stated before, all real number. So domain is all real number. What else? Range. Okay. In this case, you will see that the range is from 0, not include, to positive infinity. Right? You see that. Just from 0 going up to positive infinity. What else? I have vertical asymptote. Sorry, I have vertical intercept and then asymptote. Yeah, and that's it. So we did sketch, we did everything else. And this is an example of exponential growth. And notice that at x go to infinity, at Lx will go to infinity. We could also say that x increase, that your output values increase without bound. Additionally, as x go to negative infinity, Fx will go to 0. So we could also say that as x decrease, output value decrease and approach to 0. So that you think. So I will go down. Okay, so another problem. Now we're gonna complete the table for g of x equal to 1/2 x and below. Then sketch the graph of the function on the axis of y. So okay, so let's see what happened. I have 0, 1/2. I'm still gonna put out here x, and here's g of x. Right. So 1/2 to power 0 will be equal to 1. Okay, easily. So it's just, so again, we still have y-intercept or vertical intercept will be 0, 1, right? So 0, 1, stay here. What else? If I have x equal to 1, what I have? 1/2 over 1. And power 1 is still stay as 1/2. 1 over 2, 1/2 power 2 gonna be equal to 1 over 4, right? Because 1 square is 1, 2 square is 4, right? So 1 over 4, so I have another, so the 2 give me 1 comma 1/2, and then 2 comma 1 4, and the last and the third one is 3 is 1/2 to power third will be equal to 1 1 to power 8, will give me 3 and 1 over 8. And then you say that is keep if you keep this one higher, and then the Fx will go to 0, right? So if this one becomes higher and higher, you're going to get Fx go to 0. So yeah, so let me list out all the points. So 1 and 1/2, 1 and 1/2. 2 and 1 4, so become lower and lower, and 3 and 1 8. It's gonna be very close. Okay, so what about the other side? I will use -1 and see. I have 1/2 to power -1. Okay, now what happened? Okay, so I will make it become the reciprocal of 1/2. So that's gonna be 2 easily, right? So what about -2? I'm gonna have 1/2 to power -2. Okay, so that will give you 2 you have to receive, you have to, because the negative power, then you're gonna have like 2, the reciprocal of 1/2, 2 to power 2. Now the power negative change to become positive, and now you have 4, right? Similarly, if I have -3, you're gonna have 1/2 to power -3, and that will give you 2 to power third, and that gives you 8. So now you can have 1, -1 and 2, 1 point, -2 and 4, 1 more point, and then 3 and 8. Okay, and then now you're gonna use, actually you're gonna use other color. Okay, so I will try my best to draw this. Okay, so let's go down. Oh my God, it's not correct. Oh, it's not easy for me to draw by this way. Okay, almost. Okay, so it keep going like that. And for this side, ooh, okay. So you can see that from the left to the right is decreasing, and this is like a decaying, the decay graph. So I'm gonna say decay here, and so we're done with the sketch, the graph. State the domain. Okay, so domain again. This is a real number because it is exponential function. And what else? State domain, RD range. You will still from the left to right. You see that it's come from the positive infinity to the 0. So you're gonna say 0 to positive infinity, not include, and asymptote is the same as before. It's going to be y equal to 0. Okay, so this is an example of exponential decay. And notice that at x go to infinity, you will see that g of x is go to 0, right? So we could also say that as x increase, the output value decrease approach to 0. And additionally, as x go to net infinity, then what? Then g of x is g of x. Oh, okay. So there's a mistake. It should be a positive infinity, right? If you go to the net infinity side here, you see that the value of y of g of x is just going up. So that's the reason why. Okay, let's move down. Almost. Okay, characteristic graph of the graph of an exponential function. So an exponential function with the form a times bx and a greater than 0, b greater than 0, b not equal to 1 has following characteristic. Okay, so firstly, it is one-to-one function. Okay. And y-intercept is 0, comma a. Okay, both of these, see that? And horizontal asymptote will be equal to 0, y equals 0, right? Domain is always Oreo is negative infinity to positive infinity. Range is over. Okay, so yeah, for this case, when a is greater than 0 and b greater than 0 and not equal to 1, is we'll have range is always greater than 0 and not um, so it not include 0 from 0 to positive infinity. And in itself we don't have for increasing for this one is have like it's going to be increasing. Okay, increasing if b greater than 1 and decreasing is from 0 to 1, right? So this is increasing is b greater than 1 and this one is decreasing. B is from 0 to 1 in between. Okay, so let's move down to see what is next. Oh. All right. So this is part number 3. We want to graph on the following function on the same axis. So I would recommend to do this problem by using decimals. So using decimals to do this. Okay, so let me show you. Okay, so let's go to the decimals. Okay, decimals. Okay, so I will have fx equal to 2 to power x, right? So I have y equal to 2 to power x. That is one of them. Next one is y equal to 3x. Y equal to 3 to power x. And then the third one is y equal to 1/2. I need to put the parentheses and then power x. Oh, power x. Yeah, it looked like correctly. Okay. Then kx. So y equal to 1/3. So maybe I can copy this one. Let's change the number 2 here become 3. Okay. So so you can see that in here the first one red here. Let me see. The red one here is the 2 of x. Y equal to 2x, right? And the blue one is change blue. Blue one is y equal to 3 power x. All right. And for the green one, right? Green. Green is 1/2, right? And the purple here is y equal to 1/3. Okay, so all of them have to go through one point, which is initial, initial A here, right? And it's be like 0A, or also it's like a vertical intercept, right? Y-intercept. So and what is A in here is 1, right? So let me come back with the problem. So I would gonna draw a line. So this line, actually, I mean, in this problem, I don't wanna use by hand. You guys gonna use Desmos to do this. So all that problem I have to show you. And what do you notice for this, right? Okay, so let's come back with the Desmos. You can say notice, right? Firstly, you're gonna say like y-intercept for all function in here is 0, 1, right? And what else? Both have range is from 0 to positive infinity, right? What else? Not both, I say that all the function, all function have range. Okay. And yeah, and if you see that, say, for the base B or growth factor, base B greater than 1, then it's become increase or grow. It's going to be growth function, grow exponential function, and base is b less than 1 in here is going to be a decay function easily. So that is a note for this one, and I would love to come back with so we're done with problem 3. Okay, so now let's go down. Now I have problem number 4. Okay, so You can use the same method, but let's see if I want to use Desmos again. So, okay. So, let me clean all this. So first, I have 2x, 2 to power x. Second, what do we have? 5 times 2x. Y equal to 5 times 2x. Okay, so a little different. Now you can see that the y-intercept change from 1 to 5, right? Now what? Okay. 8 of x can be 10 times 2 of x. And what else? Negative 2 to power x. So equal to negative 2 power x. Okay. And then the last one is negative 5 to power 2. So you can see that note that, right? A A comma 0 is, no, sorry, 0 comma A is always the y-intercept. Okay. And I think this this one I just want to show you only that because it's changing the A to see the difference between the two graphs, right? Okay, and what else? If A greater than 0, then the graph, the range will be from 0 to positive infinity. But if A less than 0, then the range is changed to be from 0 to negative infinity. Okay, so we gonna stop this section here, and I will see you next time on section 5.3. Okay.